Hello dear students. So in this video we will continue our previous session, that is the numericals on static indeterminacy part B. Okay, so this is our six questions. Earlier in our earlier video we have covered five questions, and see the question: what is the static indeterminacy for the frame? This is a frame, this is a fixed support here, and second fixed support, third and fourth. We know for 2D rigid frame, we are having each fixed support is having three reactions. One is horizontal, one is vertical, and another one is third one is moment. So three reactions here, three here, three here, and three here. So 3, 4, 12. So 12 reactions, that is RE. RE value is 12, that is your external independent support reactions is equal to 12. And we are having members is equal to 12. You can count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 members. Number of joints is equal to 12 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 joints, and we know we are having one internal hinge here. So one release reaction will be calculated as summation of m dash minus 1, where what is this m dash value? M dash is the number of members meeting at this hybrid joint. So there are two members, one is this and second one is this. Two members are meeting at this hybrid joint. So 2 minus 1, m dash value is 2, minus 1 is 1. So RR value is equal to 1 here. So DSE is equal to RE minus 3. We know RE is your 12 reactions, support reactions, minus 3 is your static equilibrium conditions we have. So 12 minus 3 is 9. So DSE is equal to 9, and DSI can be calculated as 3C minus RR, as where C is the number of closed loops. So this is not a closed loop. Again, this is not a closed loop here, and this is not a closed loop again here. So we are having only one closed loop here, okay, as it is bounded by all the members. So number of closed loop is equal to 1 here. 3 into 1 minus RR is value is 1. So 3 minus 1 is 2. So DSI is equal to 2. So DSE plus DSI is equal to overall static indeterminacy, that is 9 plus 2 is equal to 11. Another approach we are having, that is DS is equal to, can be calculated as 3m plus RE minus 3j minus RR. M is equal to 12 here, R is equal to 12, and J is equal to 12, and RR is equal to 1. So you can cross verify your results with this approach also. So DS is equal to 11 here. So move on to the next question. For rigid plane frame shown in figure, determine degree of static indeterminacy. So here this is a rigid frame, that is a 2D rigid frame. Here fixed support here, this is a hinge support, this is a roller support, and this is our guided roller support. So for guided roller support, we know two reactions are acting here. One is vertical and another one is movement. And for roller support, we are having only one vertical reaction. And for hinge support, we are having two reactions, that is one vertical and one is horizontal. And for fixed support, we are having three reactions, that is one horizontal, one vertical, and another one is moment. Third one is moment. So total support reactions, that is RE is equal to 1, 2, 3, 4, 5, 6, 7, 8. So RE value is equal to 8 here. And the number of closed loops we are having 1, this is 2, this is 3. This is not your closed loop. This is an open configuration like here. Okay, so this is not a closed loop here. So 3 number of closed loop is equal to 3, and number of joints is equal to 12 here, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 number of members is equal to 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so DSE is equal to RE minus 3, that is 8 minus 3 is 5. DSI is equal to 3C minus RR. Here RR, we don't have internal hinge, so release reaction value is equal to 0. So our formula will be converted to 3C. So 3 into C is the number of closed loops we are having. So 3 number of closed loops. So DSI is equal to 9 here. So overall static indeterminacy is equal to DSE plus DSI, that is 5 plus 9 is equal to 14 here. And we can cross verify the result by the formula, with the overall static indeterminacy as 3m plus RE minus 3j minus RR. So RR value is 0 here, and by putting all these values, we are having 14 answer. Okay, so DS is equal to 14 here. Okay, so move on to the next question. And this is our approach one for static indeterminacy for beams. As you can beams are treating like a rigid jointed plane frame of open configuration, as we don't have any closed loop in beams. Okay, so our internal static indeterminacy in beams is equal to 0, as we are not having any closed loops. So DSI is equal to 3C. So we are not having C value. So it is equal to 0. So only DSE will exist in beams. Okay. So external static indeterminacy will be exist only in case of beams. Okay. So see this example. This is a fixed support, 3 reactions here. This is a hinge support, 2 reactions here. Total RE value is 5. So 5 minus, we are having 3 available equations as we don't have any hybrid joints here. So RE minus 3, that is ds is equal to 2 here. Okay. So static indeterminacy for this beam is equal to 2. So we can't consider dsi in case of beams. Okay. So this is our concept, and alternatively we can find with this formula 3m plus re minus 3j minus rr, and rr value is equal to 0 here, and j is equal to 2, and re is equal to 5 here. Okay. So ds is equal to 2 again. So move on to the next question. The static indeterminacy of beam is, so this is our beam as we are having hinge support here. This is an internal hinge. This is a roller support, fixed support. So total number of RE value will be calculated as hinge support 2 reactions, 1, 1 and 3 here. So 3, 4, 5, 6, 7. So RE is equal to 7 here. And how you calculate your RR value, as we are having one internal hinge. So it is a 2D beam. So 2D beam summation of m dash minus 1 will be applicable. So m dash value is 2. That is one member, second member meeting at this hybrid joint. 2 minus 1 is 1. So RR value is equal to 1 here, and ds can be calculated as re minus 3 minus rr. Okay. So re is 7 minus 3 minus rr is 1. So ds is equal to 3. Okay. Another approach we are having 3m plus re minus 3j minus rr. Okay. By putting all these values, member is equal to 4 here. 1. This is our hybrid joint. So this is another member 2. This is 3. This is 4. Okay. So number of joints 5, 1, 2, 3, 4, 5 here. RR is equal to 1. By this way, DS is equal to 3 also. Another approach we are having by making the whole beam to be cantilever. Okay. So by removing this hinge support here and your roller support here and roller support here, we are trying to make this beam as cantilever beam. And you can see here 2 reactions are releasing here, 1, 2. And for this roller support, 1 reaction here and 1 reaction here. So the formula or the approach to calculate your static indeterminacy is the support reactions removed to make cantilever. So how many support reactions you are removing here? You are removing here 4 reactions. Okay. 1, 2, 3, 4. Okay. So support reactions removed minus constraint added to hybrid joints. Okay. So this is a hybrid joint, and how many constraint you are adding here? RR value is your 1. So 2 minus 1. Number of members meeting at this joint is 2 minus 1. So 1 CA is value is 1. So RR value is 4. That is 2 here, 3 here, 4 here, 4, and CA value is 1 here. So RR minus CA is 3. So DS value is equal to 3 by this third approach. Okay. So you can also remember this formula also. So support reactions removed to make cantilever minus constraint added to hybrid joints. Okay. Move on to the next question. What is the total degree of static indeterminacy in the continuous prismatic beam? So what is continuous beam? Continuous beam is the beam in which more than one span is are acting in the beam. Okay. So this is AB span, this is BC span. So this is more than one span. So we can say it is a continuous beam. And what is this prismatic? Prismatic beam means its cross-sectional area is not changing here. Its material properties are not changing here. EI value is constant for this part, for this part, and for this part. Okay. So it is a prismatic beam. Okay. And we are having a vertical loading here. So here this is a vertical load, point load P acting at the span CD, and this is a uniformly distributed load. We are having a fixed support here at A, hinge support at B, hinge support at C, and fixed support at D. So DS can be calculated as RE minus external available equations minus RR, release reactions. Okay. So total external unknown reactions we are having, we are having only vertical loading here. So we are not considering our axial forces or axial reactions here. So for fixed support, we are not considering our axial force, axial reaction. So we are having only one vertical reaction and another one is a moment. And for hinge support also, we are considering only vertical. For this also, we are considering only vertical. Okay. And for this fixed support, we are considering only fixed moment and vertical reaction. Okay, so for as we know the concept that for vertical loading we are considering only your we are not considering your horizontal reactions. Okay, so available equations we are having only two this time because we are not considering horizontal. One is your vertical and another one is your moment. Okay, so total external reactions are two here, three, four, five, six. So six RE value, and equations of equilibrium we are having only summation of F by 0, Mz is equal to 0, and RR value is 0 as we are not having any internal hinge here. Okay, so ds can be find as ds 6 minus 2 is equal to 4. So move on to the next question. What is the total degree of static indeterminacy for this continuous beam? So this is our internal hinge here, and this is our internal hinge again here. So we are having a formula ds is equal to re minus 3 minus rr. Okay, so we are considering here one reaction here, one reaction here, this is a one reaction here, and here hinge support we are having two reactions, that is one is horizontal and one is vertical. If we are not giving with any vertical loads, then you can calculate your whole beam with the help of general loading. So you are considering here horizontal also. Okay, if you are having only vertical loads, then you can eliminate your horizontal part. Okay, so here as we don't have any loads here, so we are considering our general loading, so we are considering horizontal as well as your vertical also. Okay, so DSE RE minus 3 minus RR. So RE is equal to 1 here, 2 here, 3 here, 4, 5 here. Okay, so 5 here. RR value can be find as for this internal hinge, summation of M dash minus 1, that is 1 member, 2 member, 2 minus 1 is 1. And for this part, this is 1 member, 2 member, 2 minus 1 is 1. So 1 plus 1 is 2. So RR value is equal to 2 here. And DS can be find as 5 minus 3 minus 2 is equal to 0. Okay. So also we are having another approach 3m plus RE minus 3j minus RR. So you can count as member 5, RE is 5, and number of joints is equal to 6 here, RR is equal to 2 here, and by putting this value DS is equal to 0. Okay, so by this way you can calculate your static indeterminacy. Okay, move on to the next question or last question of this session. Determine the degree of static indeterminacy. Okay, so this is a fixed support here, and this is our guided roller here, and this is our slider here. Okay, so here we know for this slider roller in upward or right direction we are having only shear force will be released here. So and this for this roller, guided roller, one axial force and one moment will be released here. Okay, so total RR value will be having two value here, and third is here. So RR is equal to 3 here, and external support reactions here are 3 here and 3 here. So 6 are your RE value, 3 plus 3 is 6, and RR is equal to 3. So DS is equal to can be find as RE is 6 minus 3 minus RR is 3 again, so is 0. So you can solve this problem like this. Okay, so thank you so much for watching, and in our next video we will see the concepts of kinematic indeterminacy. Thank you so much. Please like, comment and subscribe on Complete Civil Concepts.